My name is Shumo. I'm founder of NEBRA ZKP. And today I'm going to talk about us, of course. But the vision here is that we're actually building a shared settlement layer, short for SSL, for the future internet. So a little bit background, right? I think I think most people in the room maybe think the blockchain L1 has been converged, right? So I think after the 10 years, we finally built a decentralized and censorship-resistant ledger, and it supports coded, which means Turing-complete settlement. I think this is Ethereum, right? I think there are many aspects of a system can work. For example, you cannot just compare speed with one ledger to another. For example, Ethereum has 6 different kinds of client, right? Which means there is one single client goes wrong, and the others can back up, right? So it's we finally have done that, right? There are still some major improvements in the layer 1, but it's pretty much settled. And the question to ask here is what's next? And there are just many people thinking, hey, we're going to building layer 2s, layer 3s, layer 4s, and maybe we're going to build near infinity, right? Is that the way we're going building things? We don't know, but it seems that, so this is a picture from the North Meath, the YGG Dressel, the word tree, right? So I think Ethereum is going to be the root layer of the word tree. But what's next? But we know that there's one thing certain. I do think the proofs are going to power the next 10 years, development of Ethereum-centric blockchains. So for example, we have many kind of proofs. We have proofs to settle, to scale, for example, Scroll, zkSync, Polygon, Ninja. We have the privacy-preserving proofs. For example, Semaphore, Macy, Aztec, and WorldCoin. We recently just started a collaboration with WorldCoin. I guess maybe a few people know about them. Many people know about them, but maybe very few people actually know. Z actually settle 1 million proof per month. And probably the biggest proof settlement ever happens in Ethereum ecosystem. And then we have different kind of oracles, and other people call it co-processors. I'm not going to get a name war here, but that's my slide, so I call it whatever I want. For example, zkP2P, Brevis, and Lagrange, right? So I think a big problem here is that the cost of verifying single proof is very high. I have to update the slides every single time I talk for 2 reasons. First, ETH price goes up. And second, the network getting more congested, so the gas fee also spiked, right? So for example, today, roughly, if you want to verify gross 18 proofs, you need about $22.5 US. And if you want to verify a Halo 2 KZG proof, you need $36. And if you verify a Stark proof, costs you more than $100. So this is what Vitalik Fimich said, right? Do I want to pay $20 to add privacy for my transactions to buy coffee? Probably just use as a gimmick. But so think about how much the coffee, right? I know here we're Colorado, right? The most expensive coffee I've bought is actually in Colorado. It's in Aspen. It's $25 a single espresso. That's insane. And to make it worse, it's kind of mediocre. Yeah. Right? So I think very few people want to pay $20 to adding privacy or doing whatever ZK things you are doing. So that's why we're here, right? So first, how we're going to making ZK cheaper on chain, and the answer here is using ZK, right? Basically, we're using ZK itself to make ZK cheaper. That's so first, I'm going to talk about the core technology component we're building called the ZK NEBRA UPA, which is short for the Universal Proof Aggregator. And this is a high-level overview of NEBRA UPA, right? The very high-level idea here is that we take multiple proofs, and we call it universal here because these proofs can come in from different circuits. So for example, some can be zkDID, some can be zkEVM, some can be Brevis proofs, whatever. And we can aggregate multiple proofs into a single proof and put the single aggregated proof on chain. So as a result, the ZK verification cost getting amortized. So our current number here is that we can down the proof cost to 40K in terms of gas fees from like 200K. And as we developing better and better like ZK technologies, and also with potential hardware acceleration, the cost can be even cheaper with a larger batch size. So here is this like a kind of a very simplified protocol. How does NEBRA works, right? So we first have an on-chain component, which means it's actually extremely easy to use us. You just need to send your proofs to our smart contract. And then we're going to deploy it on all the major L1 and L2 EVMs and some potentially non-EVMs like Starknet. So then once we receive your proof is going to send a distributed proving network. So we have coordinators, and then we have distributed provers and powered by GPU machines. There are three major characteristics of this protocol, right? The first is permissionless, which means we're not a SaaS company. And we basically have a protocol, and you can send your proof to us, and then we aggregate the proof, and then you get notification, and you pay your fees on chain. And second is censorship resistance. So we have a very, very similar designs to L2s, kind of like similar to false inclusion, if you're familiar with the L2 land. And then third is that we are going to be progressively decentralizable, which means first we are going to run kind of like a semi-centralized but distributed prover, also very similar to the state of art of L2s. And then we're going to have run a decentralized proving networks in the next step. And that's about the protocol, right? Then the next question is, how are you going to use us? Again, like I leaked before, it's very, very simple. On the left-hand side is how you are going to verify a proof today on Ethereum. You deploy your ZK contract, right? And also you deploy a verifier contract. Normally people name that the verifier.sol. And it contains the cost to the EVM precompile of the pairing, the BN256 pairing precompile. And now switching using NEBRA, you just call us, right? So we have a fixed deployment address on different chains, and you just remember our address, call our smart contract, and then that's it, right? So I will show you the links to register our workshop at East Denver. So we're going to do a real-time demo, and also you can actually use our testnet in our workshop. And if you actually send the first ZK transactions on us, you will get a little bit surprised with a nice gift. But that's it, right? Really nothing to say. And let me give you a little bit like technical overview here, right? So NEBRA protocol is going to be progressively being built. The testnet we're launching right now is called NEBRA UPA v1. So it actually using like 2+ layers recursion using Halo 2 KZG, right? And because we have a lot of like in-house cryptographers and mathematicians, we're actually using the Chinese remainder theorem-based field simulation with lookup. So like don't scared by the terms, but as a result, we have the best non-native arithmetic performance over the industry, actually better than PSEs and Axioms. And then under hood, we're running a pipeline and a distributed proving serving architecture. So there are two keywords here, right? First, the distributed, which means like we can have multiple GPU workers. Actually, we can spawn any number of GPU workers. And the second keyword is pipeline. Pipeline basically means the proof batches can overlapping each other, right? So this is try to increase the throughput and lower latency. And each single ones are using like GPU acceleration. So I guess a little bit sneak peek to NEBRA UPA v.2. So what we're going to build next is a proof aggregation VM, right? The biggest theme here is that we're going to support multiple proof systems. And there are some key like technical primitives we're going to use. Like first is the cycling curves for even less like non-native arithmetics, right? So this is very similar to like I guess Aztec's Goblin Planck design, but we have different requirements. We design in a slightly different way, and also we're going to have more efficient polynomial commitment schemes to designed to optimize the recursion overhead, right? And also more efficient lookups. And we are going to review more things about 2.0 later. So my analogy here is that NEBRA UPA is a very, very powerful technology, right? So I'm a space fun. So my analogy here is that we just built a Raptor engine, right? A very, very powerful rocket engine. But that's not the whole story. We need to build a rocket. So where is the rocket? Basically, if you're using NEBRA UPA's analogy of the Raptor engine, the NEBRA SL is the rocket, right? So now I will show you the rocket. So I think what NEBRA UPA actually enabled is what we call shared settlement layer. Like, what is this? So let's first look at the problems, right? So despite L2s are great. L2s are great because it actually reduces the friction and fragmentations of the entire blockchain space. So everyone doesn't have to build yet another alternative L1s to kind of building these like independent kingdoms, and it's really insecure to talk to each other. But L2 is great just to a certain extent, right? The biggest problems here is that if you look at this table, right? So I just did a little bit like categorization here, right? So L2 is great if you're moving L1 native asset from L1 to L2. In any other cases, right, there's still a lot of security issues right now. For example, if you're moving L1 native asset from L1 back to L2, it's usually very slow or you have some security risk. And things getting worse if you're moving L2 native asset from between different L2s, right? So this is a big problem. This is and also, so basically we think we can come and solve these silo problems of L2 blockchains. And this is actually, we're not coming up with this concept first, right? I think Vitalik has famous coming with this idea called proof singularity for a while, right? The basic idea here is that you should use proof aggregation to like gapping the silos between different L2s. And let me talk a little bit about how exactly we're going to do here, right? So what we're actually building here, we call it co-settlement. Basically, the idea here is that one single proof, multiple settlement. So the high-level idea here is that you have validity proof from different layer 2s or layer 3s, whatever, right? So we are going to aggregate these proofs into a single NEBRA UPA aggregator proof. And also, we bring this proof settlement to multiple places, for example, like Polygon, Scrolls, Darknet, and OP, right? And maybe I can talk about a little bit of detail here, right? So the ultimate reason we can do that is that there is no upper bound of how many proofs you can aggregate in a single proof. It's purely a matter of hardware acceleration and how much latency you tolerate, right? So the better the ZKP technology going, which is still going very fast, the better hardware, and given a fixed latency, you can aggregate more proofs, right? And then after we have the aggregated proofs, on each single places, for example, Scroll, you can do a selective opening of these proofs, which means you can only open the portion of proof you care. And because that's extremely efficient, because a single proof is very, very small, right? And what this really brings is, we call it async composability carried by proof to the entire blockchain space. And so this is still kind of in the early research stage, but we are actually committed to building this like a shared settlement layer to the entire space. And I think if you want to hear about more about NEBRA, first about the technical details, and second about our testnet and API interface, and please come to these two events. So we have an event tomorrow co-located with the D-Infra Summit. So there's a NEBRA workshop. And I know they are closed registration because it's full, but if you say, hey, refer by NEBRA, you'll get a pass. And the second one is March 1st, which is our Proof Singularity Denver. We are going to have a lot of Stokes speakers, for example, like Zach from Aztec, Robert, he's a co-founder of Polkadot. And we're going to host a heated debate. Basically, we're going to debate when you should use programmable cryptography and when you should use like programmable trust or like eigenlayer Babylon style restaking, right? It's going to be very spicy, so please come. I'll stop here for a while. And last but not least, this is a team effort. This is our team. And please follow our team members on X if you want to listen to high quality cryptographic GigaBrain content. Follow our team members. If you want shit posts, follow me. Yeah, I think that's the end of talk. Yeah, thank you.
Any questions?
What do you think of the Polygon egg layer? Because we are also talking about the aggregation layer as well as like the silo problem between the L2s.
Yeah, I think the egg layer is trying to bridge the silos, but within the Polygon ecosystem. And we are more general. So basically, I think I guess didn't show in the details, right? So our scope is just much wider in several sense. First is that we're going to bridge across different ecosystems. And secondly, we're actually bridging between applications and infrastructures. For example, you can, let's say you have a proof from WordCoin, right? WordCoin's proof can be co-settled with a validity proof, where that's Polygon's doesn't support. And I guess thirdly, most importantly, if you go back to the co-settlement designs, right? The Polygon is just like have an aggregated proof set on Ethereum, and we're doing the co-settlement on every single chains. That brings the interoperabilities between different chains, right? So I think the protocol is quite, the proof aggregation technique we're using is despite there are like a specific proof system differences, but from high level is quite similar. And I guess the other thing here, we can talk about that. We are production ready now, and we actually run a little bit stress test our systems. I think last December, we aggregated 1 million proofs. Only takes like 36 hours, which give you about 10 proofs per second. And we actually burn like 3,500 Sepolia ETH to be able to run the experiment, right? So, and I think our code audit is already started, so we'll be kind of midnight soon. Yeah.
Great.
Thank you.